students, how are you? Welcome to my session. We are right now discussing various method of solving the complex network. In our previous video, we have discussed the very first method of successive reduction. If you have not gone through my previous video, I would recommend first you go through the previous video. I have given the link in description. After that, in today's session, we are going to discuss what is short and open circuit. Okay. After that, we will discuss some equipotential points, and then what is the electrical symmetry. It may happen. Today we will take only point number 2 and 3, and then in next session we will see some numericals based on this 2 and 3, and after that we will go with electrical symmetry. First of all, what is short circuit? Okay, consider there is one network. Okay, network of resistors. Now you can see this point A and B. Suppose if I draw one network over here, say R, and if you take one battery V, current flow through this circuit is I. Now say this is point A and this is point B. Okay, so this is remaining circuit, and I have drawn only points A and B over here. What is short circuit? So if you join these 2 points A and B by a conducting wire, if you join these 2 points A and B by a conducting wire whose resistance R is equal to 0. Okay, if you join these 2 points A and B by any conducting wire whose resistance R is equal to 0, in that case we can say this is a short circuit. Okay, this path is short circuit. Now analyze this circuit. If you see A and B terminal are short circuited, in that case voltage between A and B is 0. Why? Because resistance R is 0 and B is equal to IR. If resistance between these 2 points is 0, in that case voltage drop is 0. Okay, and IAB is equal to infinite, because if you take Ohm's law in consideration, then V is equal to IR, then I is equal to V upon R. If R is 0, then I will be theoretically infinite. In practically it will not be infinite, but theoretically we can say I is infinite when A and B terminal are short circuited. Fine. So this is what short circuit is. So over here, if I short circuit A and B, in that case what will happen? Current will flow through this point C to R, and then from R it will go through this path and it will complete its circuit. It means there will be no current in these two resistors. So we can say that if you see point A and point B are short circuited, or if they are on same potential, because potential over here is 0 and over here is 0, or you can say if you see any 2 points, between them potential difference is 0, you can say VAB is equal to 0. So in any circuit, if you find any 2 points, between them if potential difference is 0, you can join these 2 points. So what we can do is we can redraw our network like this. This is R, this is point C. Now remove this circuit V, I and R. Got it? So if potential difference between 2 points is 0, then no current will flow through these 2 points. In that case, you can remove the part from the circuit. Okay, so this is the importance of short circuit. when we will discuss our numericals, in those numericals we will try to find out some points which are short circuited or potential difference between them is zero, and if we find any two points between them, if potential difference is zero, in that case we can join them, or this circuit we can remove. Fine. So this is what the short circuit is. Now let us discuss second thing, which is totally opposite of short circuit. It is open circuit. What do you call open circuit? If this point A and B, these two points are not connected by any equipment, whether it is a voltmeter, whether it is ammeter, whether it is a resistance, whether it is a capacitor, anything. If nothing is connected between A and B, then these two points are open circuit. Okay? This is open circuit. Now, if it is open circuit, then resistance of any open circuit is infinite. And if resistance is infinite, in that case, current is zero. Fine. So, always remember two things. In short circuit, resistance is zero, and here in open circuit, resistance is infinite. Number one. Number two, in short circuit, current is maximum, or theoretically it is infinite. Over here in open circuit, current is zero, and in short circuit, potential difference between A and B is zero. But over here, whatever potential you give, suppose if you connect a battery of 10 volt over here, in that case you will get all 10 volts between points A and B, means VAB is equal to applied voltage. Fine. This is what the concept of open circuit and short circuit. Okay, I hope it is clear to you. In short circuit, current is maximum, or you can say it is infinite, resistance is zero, and potential difference between these two points is zero. And if potential difference between any two points is zero, then you can join these two points up. Okay, fine. Now let us discuss equipotential points. Okay, so now let us continue our third topic, equipotential points. First of all, try to understand what the name equipotential points try to suggest. Equipotential means the points which are at the same potential at equal potential, right? Okay. If this point 1 and 2, if this point 1 and 2 are having the same potential, suppose V1 and V2, then difference between them means delta V, V2 minus V1 is equal to 0, because both are at the same potential. In that case, from Ohm's law, we can say that if delta V is equal to 0, then IR is equal to 0. In mathematics, we have seen that if x into y is equal to 0, it means x is equal to 0, or y is equal to 0, or x and y both is equal to 0. Here we are saying that equipotential point, if points 1 and 2 are equipotential point, in that case potential of V1 and V2 are are equal. It means potential difference between them is 0. If potential between them is 0, in that case from Ohm's law we can say that I into R is 0. Now come to mathematics. If the product of I and R is 0, so there are two possibilities. Number 1, R is equal to 0 and I is not equal to 0. Number 2, I is equal to 0 and R is not equal to 0. So what we can do is, Let us take case number 1. If R is equal to 0 and I is not equal to 0, in that case also product of I and R is 0. In that case delta V is equal to 0. In that case these two potential are same. So if I join point number 1 and point number 2 by a conducting wire whose resistance is 0, in that case potential of this point means V1 and potential of this point V2 is same. It means V1 is equal to V2. It means delta V V2 minus V1 is equal to 0. It means IR is equal to 0. Okay. So this is a pure case of short circuit. What we have seen here, short circuit. Okay. Earlier also I mentioned that if two points are at same potential, or if you find that these 2 points are equipotential point, then you can join these two and you can reduce your circuit like this. I think it won't be visible. I'll redraw the network, simplified network over here. This one and this one. Join this 2 point. So like this and like this. Okay. So this is what we will get in case number 1. Okay. If R is equal to 0 and I is not equal to 0, it means it can be, you can consider this case as a case of short circuit. Now, second case, if I is equal to 0 and R is not equal to 0, then you will say that sir, it is a pure case of open circuit. But in open circuit, what we have seen that R is equal to infinite. R is equal to infinite. But you may get some of the network in which R is not equal to 0 and even R is not infinite. R is having some finite value, means 2 ohm, 3 ohm, 4 ohm or something like that. Okay. In such cases, R is not infinite. Even though you will get current through that particular resistor is 0. Say this is one Western bridge. Okay. Now if you find that current through this C and D, current through this C and D branch CD is 0. So over here resistance is finite. Resistance is finite. Even though current through this particular branch is 0. Now current through any branch is 0, it means there is no potential difference between C and D. In 10th standard also you have learned that current will flow from higher potential to lower potential. If there is no potential difference between any 2 points, no current will flow. Over here there is no current between C and D. It means potential of C and potential of D both are same. Okay. So VC is equal to VD. Over here you can say VC is equal to VD. So C and D are equipotential points. C and D are equipotential points. So what you can do is, in such cases there is no current through this resistor, so you can remove this particular resistance. Okay. So how to use this thing, that we will see in our next video when we will discuss some complex network examples. But right now you just need to identify which are the equipotential points up. So you can join this point C and D. Okay, you can join this point C and D. So your network will be like this. This is point C, resistance R. Now C is equal to D. So this second resistance R. Okay, again this and this. Okay, join point C and D. So R by 2, and this one is also R and R in parallel. So R by 2. R by 2 plus R by 2 is R. So you can say the equivalent resistance between A and B is R. We will find equivalent resistance later. Right now you just have to identify which are the equipotential point. So last time let us revise it very quickly. Equipotential points means points who are at the same potential. It means V1 is equal to V2. It means difference between them or potential difference between them is 0. Now if delta V is equal to 0, it means from Ohm's law you can say I into R is 0. If product of I and R is 0, in that case if R is equal to 0 and I is not equal to 0, then also product is 0. R is equal to 0 means you join these 2 points by a conductor whose resistance is 0. So V1 is equal to V2, so delta V is equal to 0, then IR is equal to 0. Then 1 and 2 are equipotential points and you can join them. So 1 and 2, you can join these 2 points. Second thing, product of IR is 0. Over here I is 0 and R is not equal to 0, but this is not a case of open circuit, because in open circuit R is infinite. Over here R is finite. So in which case this will happen? I have drawn this circuit, and in this western bridge, if there is no current in branch CD, in that case you can say that potential of C and potential of D are same, VC and VD. Means there is no potential difference between C and D. It means there will be no current in branch CD. Okay, so C and D are equipotential point. You can merge them, you can join them. So what I have done is, over here you have point A, this is point A, R, point A, R and D. So here I have joined C and D, then C to B, R, and this B to B, R. So R by 2 and R by 2, equivalent resistance will be R. Okay, this is our third method, equipotential points. Now we will discuss some more numericals based on these three. Okay, now let us discuss fourth method, which is electrical symmetry. If you find symmetry in any given circuit, in that case you can join 2 points and you can simplify the network. Consider this particular network in which, say, from here, from this point, 2I current is coming towards point A. Now if you find that from this branch AB and another branch AC, you have same current I and I, means in this two branch, if current is same IAB and IAC, so I is equal to IAB is equal to IAC. Number 2, resistance between point A and B and resistance between A and C are same, means R is equal to RAB is equal to RAC. In that case, obviously if I and R are same, then potential drop or potential difference between point B and A, as well as potential difference between C and A are same. If VAB is equal to VAC, then point B and point C are equipotential points. In that case, you can join them. In that case, you can join them. And then you can find the equivalent resistance of the given circuit. Let us discuss one example. Suppose you are given this network 3 ohm, 6 ohm and 1 ohm. 3 ohm, 6 ohm and 1 ohm. 3, 6 and 1. Okay. This is point A and point B. Now you have one short circuit connection like this and another short circuit connection like this. Okay. What you have to do is you have to find the equivalent resistance between points A and B. So this is point A. Consider this is point C. Point A and C are short circuited, means there is no potential difference between point A and C. In that case, we can say that VA is equal to VC. Okay, these two are equipotential points, means you can join them. So to simplify the circuit, what I'll do is I'll join A and C. Apart from that, this point B and say this is point D. This point B and D are short circuited. It means they are at same potential. So VD is equal to VB. There is no potential difference between point B and point D. So they are equipotential points. What you can do is you can join point B as well as D. Okay. So how to draw the simplified network? From A, I can draw a 3 ohm resistor and it is going towards B. So A and B having the 3 ohm resistor. Now B to A. Okay, B to A, you have another 6 ohm resistor. So this is another 6 ohm resistor B to A. And now this 1 ohm resistor is connected between A and B. 1 ohm. So 1 upon RAB is equal to 1 upon this 3 are in parallel, 1 upon 3 plus 1 upon 6 plus 1 upon 1. Take LCM as 6. So 2 plus 1 plus 6, 9 by 6. So RAB is equal to 6 by 9. 3 2s and 3 3s are 2 by 3 ohm. So RAB is equal to 2 by 3 ohm. Okay, so this is your answer. Fine. So this is the way you can simplify the circuit. Now let us take one more example of electrical symmetry. Okay, now consider this circuit. Suppose you have to find the equivalent resistance between point A and B. You have to find RAB. 2 ohm resistor is connected between A and B. This 1 ohm is connected between A and D. This 1 ohm is connected between D and B. 1 ohm between D and C, and this 1 ohm between C and B. Now this dotted line shows that this 1 ohm resistor and this 1 ohm resistor are not connected to each other. Okay, it is going behind this particular wire, means these two are not connected. Okay, now what we can do is in such circuit I can use electrical symmetry. How? Consider point A, D and B, because you have to find the equivalent resistance between RAB. So consider this path ADB. You will get 1 ohm resistor between A and D and 1 ohm resistor between D and B. Similarly, consider this path ACB. You will get 1 ohm resistor between A and C and 1 ohm resistor between C and B. Means you will get electrical symmetry in ADB as well as ACB. So from the given figure, D and C are equipotential points. Therefore, VD is equal to VC. Okay? And if D and C are equipotential point, in that case, this 1 ohm resistor can be removed. So, equivalent circuit will be like this. This is 1 ohm, point A, point D. From this, point B, this 2 ohm resistor, this is removed. So between B and C, you will get 1 ohm resistor and this 1 ohm resistor like this. Now ADB, this 1 ohm and this 1 ohm resistor are in series. So you can say between A and B, 2 ohm resistor is there. Okay, ADB. Consider this part ACB. This 1 ohm and this 1 ohm resistor are in series. So 1 plus 1 means 2 ohm. And this 2 ohm resistor is already connected between A and B. So you can write over here, this one is also 2 ohm. So RAB is equal to 2 by 3 ohm, because we know the rule, if same 2 ohm resistor are connected in parallel and 3 resistors are there, in that case you can directly say that value is 2 by 3. Okay, so with the help of this electrical symmetry you can simplify such complex network. Okay, thank you. In next session I will come up with some new techniques, some new methods, and we will enjoy the session. Thank you.